All right, welcome to Lecture 10, Parte dos. Okay, now we are going to look at binary covalent compounds. That is to say, we're going to be looking at the compounds that only involve two nonmetals. Okay, covalent compounds can get much bigger. Organic compounds in particular are pretty huge. Like DNA is kind of ridiculously big. Plastics tend to get huge, but we are just going to be focusing on binary. Okay, so only two elements. Now these are straightforward and simple. You're just going to have to do a lot of memorizing. Because the way it works is we have to use lots of prefixes. Namely, let's see, for 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And that's where we're going to stop, just because although you could try and get bigger things in there, it gets kind of awkward. So, mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. You can go above 10. For example, 12 is dodeca. 20 is icosa. Okay, but you don't have to remember 12 and 20, just 1 through 10. You need the prefixes because, unlike ionic compounds, the subscripts are not fixed by the elements and ions involved. Remember, you can get nitric oxide, dinitrogen monoxide, nitrogen dioxide, dinitrogen dioxide, and so on. You can get, there's like a dozen of them. So you have to have the prefixes in there. And thus, for the binary covalent compounds, you are only ever going to be expected to go from formula to name and back. Okay, the elements involved, unlike the ionic compounds, would never be sufficient. Okay, they are often sufficient for the ionic compounds. So let's do a few examples, and we'll talk about some exceptions. So let's see. In 205, this is dinitrogen, because there's two nitrogens. Pent oxide, because there's 5 oxygens. And here's our first exception. You don't throw in the final vowel before oxide, just because it sounds kind of weird. Okay, so CO, carbon monoxide, not carbon monoxide. Okay? The exceptions to the exception are di and tri. So you can have CO2 is carbon dioxide, and S2O3 disulfur trioxide. Okay. So you can have all sorts of things, obviously. And this also serves to highlight the other exception here and here. No mono in front of the first element. Okay. We just don't do it because we don't. There might be a good reason. There probably is not. Now, there are also what are known as common names. These show up all the time in organic chemistry. They also show up for a bit of inorganic chemistry. So, for example, this here, you might think this was supposed to be, it is supposed to be, in fact, nitrogen monoxide. But instead, it is known as nitric oxide. Again, there's probably a reason. Might not be a good one, but there's probably a reason out there. I don't know what it is. So, just to fly through a few more examples. Let's see. So 4 into 4. I'm going to do something other than oxygen, because, that just gets boring. Let's go CCl4, IF5. So let's see. Go ahead and pause the video now, give it a shot on your own, and then come back. Welcome back. Okay, so this is carbon tetrachloride. And this here is iodine pentafluoride.
And when she passes, he smiles, but she doesn't see.
Okay, so let's take a look at these three. I'm assuming you paused it and then came back. Good for you. All right, this one is ammonia. Yeah. Again, common name. Sometimes they just stick around, and ammonia is one of those. This one is carbon disulfide. And this is hydrogen sulfide. It should be dihydrogen monosulfide, but it's kind of not. I'm not really intending to throw in these exceptions necessarily, but they're useful. Hydrogen sulfide. This is the rotten egg smell that they talk about. It's only slightly toxic. Here we have iodine trichloride, and this is phosphorus tribromide. Okay. Be careful. The IDE, the ending means we're looking at a compound of some kind. It does not mean we're looking at an ionic compound. Okay. Prefixes tell you that it's covalent. Complete lack of prefixes will tell you probably that it's ionic. Another thing to look for, they're both nonmetals. Okay. If you have a metal involved, probably not a covalent compound. Not that it's impossible to have metals involved in covalent compounds, just that it's rare. Now, naming alloys. We don't. Okay, that's beyond the scope of this class. So, when we come back in the next lecture, I'm just going to go ahead and call it here. This has been kind of short, kind of easy, I hope. But when we come back in the next video for Lecture 10, Part 3, we're going to cover acids and oxyacids.